Okay, so now I'm asked to draw the image of triangle A after a rotation of 90 degrees clockwise around 0, 0. So let's take a look. If we are rotating 90 degrees clockwise about 0, 0, then the center of rotation is here. And every point on this shape needs to turn 90 degrees relative to that point. So what I like to do is I like to build an arm. Here's my little arm, and I want to rotate that arm 90 degrees. It would end up going over here, remembering that we're supposed to be rotating clockwise. Now my entire shape, it's pretty easy to imagine what a 90 degree anti-clockwise rotation would look like, and I just have to pivot now around that point. So this line, which is horizontal, would now go vertical up here. This horizontal line, which is 3 units long, this vertical line with 3 units long would now be horizontal, and then the diagonal will connect like this. And as long as your picture makes sense, then you know you've done it right. So there's my first bit. But now once again I'm asked for a matrix that represents this transformation. So here is what we do. Again, I'm going to imagine what would happen if I applied this transformation to 1, 0 representing our x's and 0, 1 representing our y's. So 1, 0, an x coordinate, which would look like this on my diagram, would rotate around 90 degrees and it would end up at 0, 1. But if I had a 0, 1, a y coordinate, so this is for x's and this is for y's, if I had a 0, 1 and I rotated that one around, it would end up down here at minus 1, 0. Now whatever happens to the x's goes in the first column of the matrix, and whatever happens to the y's goes in the second column of the matrix. So the x's end up being 0, 1, so that's what goes here, and the y's end up being minus 1, 0, so that goes over here. This might seem a little bit odd or random to you, but really for the purposes of your course and your exam, you're best off just learning this method and following it. If you do A-level further maths, you'll get a chance to get more understanding and more insight into why this works. So there's our transformation matrix for a rotation. If you want to check a matrix, you can always see if it works with one of the points that you've worked out geometrically. So let's take this point over here. This point has an x value of 3 and a y value of 1, and it ends up over here. It has an x value of minus 1 and a y value of 3. So if this transformation matrix over here is the right one, if I apply it to the 3, 1 vector, it'll give me the minus 1, 3 vector. I'm just going to check and verify that now. So I'm going to apply my transformation matrix, which is my 0, 1, minus 1, 0. And I'm going to apply that matrix to the point 3, 1, the original point on the shape. I'm expecting that I'll get this new point over here. So to get the entry in the first row, I'm going to do first row times this column. 0 times 3 is 0, and minus 1 times 1 is minus 1. To get the entry in the second row, I'm going to multiply the second row of this by my vector. 1 times 3 is 3, and 0 times 1 is 0. Adding those together gets me 3. So we have confirmed at this stage that the 3, 1 would map to the minus 1, 3 using that matrix, and I can be fairly sure I've done this thing correctly now. This step isn't necessary, I'm just trying to walk you through what it actually means and what it does. Let's carry on to the rest of the question. Point P has coordinates 4, 1, and F and G represent transformations. I want to find GP, the image of P after the transformation represented by G. So this is just a case of multiplying together the matrix and the vector. So GP is worked out by going 1, 0, 0, 2, the matrix G, applied to the vector that matches this point, which is 4, 1. Okay, so I'm going to work out what this is using my usual matrix multiplication. 1 times 4 and 0 times 1, add those together, I get 4. 0 times 4 and 2 times 1, add those together, and I get 2. So GP is equal to the point with coordinates 4, 2. Now I'm asked to find GFP. And I'm going to do that in the next video.